Right, g'day, you're here with Luke, Beattie and Luke Checker from GenZ Energy. We're just doing a series of videos on all things batteries. So at the moment with the Cheap Home Batteries program, it's all about batteries at the moment, from residential, commercial, up to utility scale. Today we'd like to talk about safety in GenZ products and some of the considerations for people, because we know the worst case scenario is seeing house fires, fires in businesses.
Or just any fire in general.
Any fire in general is pretty bad.
It's pretty bad to start,
I mean, you see on the news, a lot of the fires are things like the scooters, electrical devices.
Small scale, those like electric control cars, those sort of problems.
So the charging's not being managed, overcharging batteries and causing all sorts of fires. So this is a GenZ product, one of our rack mount batteries.
It is.
And we're just going to talk through some of the safety features, but it's not just for our products, it's broader considerations for all the products out there, I suppose.
Fine,
Do you want to start with the first line of safety, which really is the chemistry of the batteries themselves? So
the building blocks for the battery itself, right? The cells themselves. So all of our GenZ products, they're all lithium ferrophosphate cylindrical cells by design. The reason we've gone with that, and I think most of the market will agree, is that lithium ferrophosphate is currently the best commercial option for those thermal stability and the current energy density that it gives. Whilst it's not as energy dense as nickel, manganese, cobalt, what we do get from that trade away is we get thermal stability, which is probably one of the biggest and most important points for home energy solutions. Because if it's having good thermal stability means it's more robust against fire and thermal runaway, which is what you start seeing in those nickel, manganese, cobalt options, which is the scooter fires, and that they're typically caused from that sort of application.
Because they have really high energy density,
That's
right?
the one,
so if you look at phones, laptops, scooters, they have the NMC technology.
That's the one.
And there's also lithium ion technologies as well.
There is other lithium ion chemistries in that space.
But then you have lithium ferrous phosphate, which is in our batteries. So the chemistry. I'm interested about the cells though, because we see a lot of the cells in market are going towards a prismatic cell. And we have cylindrical cells. So do you want to speak to that?
Yeah, sure. Having a cylindrical cell, one of the most important bits about that is it allows a larger surface area for cooling and thermal, and that allows the better equalization of temperature throughout the pack. It also, the trade away from that being is that we don't get the same packing density that you get in prismatic solutions. But we believe this trade away was worth it. I mean, our bread and butter came from radio clients in the mine sites and in the Pilbara, and the cylindrical cell is vitally important to maintaining the ambient temperature of the battery pack to lay at a lower temperature and be able to equalize with those internal racking solutions.
Better in some of those harsh conditions, like going to the Pilbara, the Kimberley, back into Queensland, places like mine sites. And like you said, GenZ cut its teeth doing communications infrastructure. So basically batteries supporting radios, microwaves, that sort of thing. So we've got lithium ion cylindrical cells. What are some of the other features that have been adopted here for safety?
Right, so obviously, as we know, these cells then get piled into a pack. The pack then gets put into the battery itself. And then in that process, we then have a battery management system, which then manages the electrical state and the temperature state of the battery pack. So the battery management systems, they've been around for, since lithium ferrophosphate got adopted into the industry, mainly to manage things like over voltage, under voltage, over current, over temperature. These core protections are needed because unlike their lead acid counterparts, if you do overcharge even lithium ferrophosphate batteries, you're going to run into some problems there, which emphasizes the importance of a good battery management system. So we spent a lot of time developing a battery management system solution for this battery, and then having that integrate into our what we call as the ZDC. And that basically takes all the telemetry data that's produced by the battery and then relays that to customers. And the importance of this is that remote monitoring is quite important for some of our clients, and it also helps people look into the batteries to see how they're going for like warranty and all those sort of other implications.
One of the things I found interesting is that we had a particular client servicing a DNSP, and we've had the same thing with emergency services infrastructure too, where they had certain requirements of the reporting first of all, and then the controls, because sometimes they want remote controls for these things. Sometimes they don't want those remote controls because it could be, a chink in the armour, or it could be a way for someone, a security risk, exactly. So having that system to let you know or to alert, and they're quite specific about what they wanted. So what I found really interesting was that was communicated. Our team, of course, had some really good programmers in it. And
not me. There's other programmers.
You're no slouch, but within 24 to 48 hours, some of these bespoke controls and monitoring were implemented in there for that particular project. I found that interesting. Just for the controls for safety's sake,
Yep.
I suppose it's not just about a remote monitoring platform, it's about what the BMS is doing there and then.
Yeah, exactly.
Being able to monitor.
I mean, the BMS is a functional safety device. The most important thing the BMS does is it ensures that no matter what's happening on the outside of the terminals, it is going to make sure that the cell pack itself remains within its operating parameters. And now on that point as well, the validation of the BMS is done by external standards, IEC, AS, and CEC, that really emphasizes the importance of these, I would say, institutions in our society, because what it does most importantly is it validates that all home energy solutions have these battery management systems in place to keep the cells safe. Now, that being said, there is other protections that we have on the battery itself. We've got the circuit breaker on the front as a kind of a second line of defense. Technically it's tertiary because the cells all have an individual protection device. But the circuit breaker allows you to isolate the battery when doing home maintenance and all that sort of
I suppose even for shipping.
Yeah,
so
that'd be important as well.
The standards and regulations are currently changing. The TS, whatever numbers come after that, in that it's all about not having any voltage at the terminals until it's plugged in.
Yep.
And having a circuit breaker gives you the opportunity to isolate it, shut it off, can ship safely, can be installed safely, can be serviced safely until you want to flick it on, and then you flick it on.
And then you've got power at the terminals. Well, provided the BMS is saying that everything's all good to go.
Yeah, very good.
So aside from the circuit breaker, then there's also the communication ports, which you'll see over the far side, which is what you were mentioning earlier. So the ability to get information out, not only does that allow you to, monitor to see what your batteries are doing. Everyone loves looking into your home and seeing that you've got power for the night, or more importantly, that it looks like you're not going to have power for the night if you've had a bad solar day. But yeah, then it also allows you to get that information out, and then some of the clients then use this for remote shutdowns and all that sort of thing to make sure the room's fully isolated before sending somebody in. It's not as important in the home energy market because obviously we don't need to have those same precautions because we're not dealing with those currents and voltages. But for some people, it's quite an important system to have.
And because we go everywhere from residential to CNI industrial applications, where it's funny the different profile of usage that you get. So the charge rates on residential and how you cycle a battery is actually quite gentle compared to some of the industrial applications.
That's the one.
And that will have an impact on battery life and degradation and things like that. But obviously that's accounted for depending on who we're dealing with. But it's good to see that in Perth, Australia, for those who are West Australian, we're quite proud.
We are,
that we're developing products, that we're innovating, and that we're there on the cutting edge and being able to offer customized solutions, but also very robust and safe off-the-shelf solutions. So
and the other thing that we are quite proud of being in this space, being able to work on all this personally here in Perth, WA, is that we get to be on the front lines talking to people about what they need to see in their product spaces, and then being able to integrate those directly into the solutions that we provide. That's been quite a large source of pride for us, being able to work here in Perth. It means that we get to see lots of unique problems every day because, as you said, some of the clients want to drive the batteries pretty far outside of their service envelope.
Like they stole it. It's true.
That indeed,
But all right. Thanks for sharing on the safety features of GenZ.
No problem.
I've learnt a couple of things, so that's good. Hopefully you guys have enjoyed it too.
Cool.